So ladies and gentlemen, the session on debates on September 5 of the International Teleconference on EPR argument is open. I should indicate up front that this session, unlike the other session, but this session is fully recorded. So we are now being recorded. The reason being that we will our technician, webmaster, will edit, remove, for instance, everything up to here, and then eventually the recorded session will be added to the series of lecture. I think that will stimulate a number of viewers to open questions, and again, I've been absolutely very pleased about the number of questions, because they indicate not only the interest, but also they indicated the number of fundamental open problems in science, in all quantitative sciences. I mean all, from mathematics to biology. And it's hoping that some of those problems can be quantitatively resolved, or at least addressed. We, at the Santilli Foundation, we are doing all possible efforts to locate funds for research grants for qualified, not only for qualified research. I think all participants are qualified, but for giving priority to important documents. I also have to be on record to recall that yesterday we have been hacked at 10:05 a.m. New York time by this occurrence has been independently confirmed by Per Nick, which is our provider, one of the best in the United States. I've been their customer for 20 years. And they apparently, the hacker tried for 2 days to halt the broadcasting of the lectures. And finally, they succeeded yesterday, but Per Nick was fully informed in advance. They have algorithm informing about this gangster type of scientific gangsterism. And indeed, essentially what they did, they immediately reconstructed the website. The website on World Lecture Series had been totally destroyed by the hackers. The hacking was also confirmed by a special investigative agency in New York that I immediately called, and I used it in the past for delicate operation. They have initiated now systematic search worldwide on the origin of where the hackers are located. But we already know, ladies and gentlemen, we are adult and scientists, and we should not be afraid of indicating the reality. The hackers, at least the most plausible hackers, are representative, as I indicated yesterday, of this organized scientific interest on opposing the quantitative, professional, democratic, and respectful search for verification of the Einstein vision that quantum mechanics is indeed an incomplete theory. It is also, ladies and gentlemen, we should indicate it clearly that among all the organized interests opposing the confirmation of Einstein vision on the lack of completeness of quantum mechanics, the biggest one are at the particle physics laboratory. They've been the most cheerful against the studies through decades and decades. And so this we're talking about very likely to represent the unauthorized representative of the CERN, Fermilab, Bayesian, perhaps other. They are on record, they are on documented record to have opposed the research by discreditation, namely by action which is not scientifically correct, rather than writing paper opposing disproving our study. There is no scientific paper on record today disproving the apparent verifications of Einstein vision that quantum mechanics is not a complete theory, particularly on the strong interaction. Therefore, with a direct relevance for the elaboration and the production and prediction of numerical results in particle physics laboratory. Okay, the panelists today are beginning from top left is Professor Thomas Vojuklis, mathematician from beautiful Greece. Then there is Professor Simone Beghella Bartoli from Italy, Professor Alex Animalou from Africa. But perhaps the most important panelist is a lady that I'm sure you will like to see, and namely my wife, Carla Santilli.
Hello, hello everybody, and welcome. And it's so good to see many new friends and many old friends. So I will be reading the questions, doing my best. From Professor George. I'm not a mathematician, but I noted that your development of Santilli's isodifferential calculus is formulated over conventional fields, thus being inapplicable to physics for the reasons indicated in tutoring lecture 1. Please indicate whether you are interested in developing the isodifferential calculus on isospaces over isofields with iso units hat 1 equal 1 over hat t bigger than 0, so that we can use your results in applications. Thank you.
Now, perhaps I can answer, make a comment. I will discuss this personally with Professor George. It is an old, very serious issue from a mathematical viewpoint. Namely, there is a schism, a separation between the magnificent mathematical work on the isodifferential calculus and physical applications. And the primary reason is that the majority of the literature on the mathematical literature on the isodifferential calculus is formulated on ordinary numbers. Now, as I indicated in my tutoring lecture, from a mathematical viewpoint, this is absolutely impeccable, because as I stated, mathematician can formulate his methods in any field he wants, he or she wants to decide. Now in physics, no. You see, without a formulation of the isodifferential calculus on iso numbers, first of all, the proof of the EPR argument will be impossible, but assuming it will be possible, it will be invalid because it will not be conserved over time. And then for another reason is that isodifferential calculus implies at the operator level non-unitary transformation. But non-unitary transformation, it is known to violate causality. For instance, this was when one read books on Lie algebras and Lie theory, such as a book by Larry Biederman on rotational symmetry, he repeatedly states, beginning from the summary and the abstract, that fractional eigenvalue of the angular momentum violate causality because they can only be achieved by a non-unitary transform. Violation of causality means the total collapse of any physical sense. The only way to recover causality has been by reformulating the theory over isofield, in which case we reconstruct a unitarity at the isotopic level, isonitarity, and then everything works beautifully, and the numerical results of pertaining to the proof of the EPR remain valid over time. I will discuss this personally with Professor George. Carla, why don't you pass the second question?
I have question number 2 for Professor Vojuklis, Santilli, and Georgia, of course, when he comes. I know from Professor Santilli's work that any ordinary nonlinear differential equation can be turned into an identical linear form, verifying linearity in isospaces over isofields, open bracket, isolinearity, close bracket, with ensuing simple solution. The question is whether it is already known that such a property can be used for the constructions of solution of nonlinear differential equations, namely whether the simple solution of the isolinear isoequation is also a solution of the corresponding nonlinear equation. If not, can the issue be investigated by some mathematicians experts in isomathematics.
Professor Vojoklis, any comment?
I think that the intention of ISO properties is to turn from to turn into linearity in order to phase. So I think it can be done this. I suppose I did not work on this because it is on analysis, but I suppose that from several spaces we can go to special ISO spaces in order something turn into linear in ordinary form.
Let me make a comment. This is at the very, very heart of the completion of quantum mechanics into hadronic mechanics or any other mechanics, if you want, that verifies the EPR argument. Why so? Because the completion is needed for the additional nonlinear, non-local, and non-Hamiltonian interaction, particularly the nonlinear interaction. Those are the central need. Now, the solution has been achieved by embedding all, and I repeat, all nonlinear terms into ISO unit. And once it's embedded in the ISO unit, essentially they are topologically removed from the space because they are positive. The ISO unit remain positive definite, and so therefore that allows their achievement of isolinearity. So by using the same principle, it is possible. Actually, it's very easy to. So you write any nonlinear differential equation, and then it's very you construct an isospace in which all nonlinear terms are embedded in the ISO unit.
Yes.
And then the equation becomes, from an extremely complicated equation, turns out into an equation which is absolutely elementary. It's just very, for me, it was very rewarding to see that, because that's the very meaning of to simplify, not to make it, unless with this, without this simplification, the handling of the most general conceivable nonlinear, non-local, and non-potential interaction would have been impossible. No, but turning in this way would have been Professor Vojoklis, please, I repeat twice, see whether there is a mathematician anywhere in the world, but I believe the most receptive to novelty are in the land of democracy, which is beautiful Greece. And it has been the case.
Yes, you see, a specialist in this topic was Professor Tsagas, you see. Professor Tsagas, he was a specialist in this geometry. But I think, for example, if you have a spherical representation, then if you have to map on a plane, then maybe in this form it will become linear. It is an assumption, I don't know.
Exactly. Yes, it is, I agree. And thank you for mentioning the later, my personal friend, Professor Gregorio Tsagas. It is true that I miss him every day. I work. I miss the breakfast spot. I miss the Tsagas. We have created a school on isomathematics, and on a truly seminal work. I would recommend we should organize an international conference solely devoted to the contribution by Professor Tsagas to isomathematics. There are many. He introduced the first notion of isomanifold, and as well as he was the biggest expert worldwide on iso-Lie theory, etc., etc. I believe that some of his students will remember the teaching by Professor Tsagas, and will continue his seminal work, because these contributions are fundamental, in my view, to resolve the major problems of afflicting our society, such as the recycling of radioactive waste. It cannot be done with linear mathematics. Ladies and gentlemen, quantum mechanics, linear and the wave function, let's be honest, those are complex problems. Or the achievement of full combustion, done with the linear quantum chemistry. Ladies and gentlemen, we have to be honest with each other. We cannot do that. So, and similarly for other solution, future solution of problem affecting. So each of those problems are, that's why we gave priority, because we know what are the implications for mankind. And therefore, hope that mathematician will answer. Thank you.
Okay, I have now question number 3 for Professor Vogiuklis, Santilli, and Georgia when he comes. Santilli has formulated the conjecture that his isotopic, isosimple, isoalgebras in n dimensions unifies all compact and non-compact Lie algebras of the sums of the same dimension. Has any study been done in this conjecture? Thank you.
This is one of the major contributions by Professor Tsagas. So let me report it. You see the ISO unit you see in Euclidean space, the ISO unit is as a compact topology. But if you go in space-time, the topology becomes non-compact. So therefore, it's very easy. You change the minus in the diagonal terms of the ISO unit. In this way, it's very easy to see. This was a conjecture that I formulated in '78. Well, Professor Tsagas wrote a book in which he did achieve what he called isotopic unification of all simple algebra, the classical algebras. And he was, when he died, extremely unfortunately, when he died because of cancer, unfortunately, when he died, he was in the process of completing this very important classification with the addition of nilpotent algebras. And I do not know, I wish I could go and search among the papers that Professor Tsagas wrote, because I'm sure maybe the solution of the addition of nilpotent is not that simple, so to say, because it's, algebraically, topologically, but it's very, very intriguing. But nevertheless, it's important for physics, because one of them, there are ways in which the Dirac equation can be written with axioms that are nilpotent. So therefore, we are talking about inclusion of the nilpotent algebra is fundamental for what we are doing indeed, especially but we're talking about carefully, we're talking about iso-nilpotency, and nilpotency refers to an arbitrary positive definite unit. So another reason to organize a conference in honor of the work and image and the teaching by Professor Tsagas.
I have now question number 4 for Professor Vogiuklis. We have seen the great variety of HV hyperstructures you can construct from few elements. Is it possible to introduce, quote, restriction, close quote, reducing such a variety so that we can start to study some elementary difference between an inorganic and organic molecule such as H2O? Thank you for your answer.
I have to remind you that in 1974, I was working with Professor Tsagas in differential geometry. We had a couple of papers with him. However, I removed to Lie algebras, so it was very hard to collaborate with him. But I think that if it is possible to do a conference about his theories, it is a very good idea. Now, about my question. Yes, in application, the hypergroupies work in this direction. We ask for axioms. We ask for more axioms because the number of hyperstructures defined on the same set is very big. It is better for us to have more restrictions. So when first, in the beginning, Professor Santilli asked to have one single element as a unit element, zero element, one inverse element, so on. It was very good for us, the hypergroups, because we restrict the great number of these hyperstructures and focus to the ones that the axioms are valid. So we don't have a way to reduce the great number, but we ask to have a lot of restrictions. So the problem is how to understand the mathematicians, the hypergroupists, how to understand the special properties of the physicists or chemists have. For example, between an inorganic and organic situation, we don't know how to transfer this in mathematics. So we have for every restriction to discuss with you, the applied mathematicians, and to see how to transfer these restrictions in hyperstructures. And if we transfer, we can reduce dramatically. You see, from equation to the non-empty intersection, it was very big enlargement of the hyperstructures. So the opposite can be done in a way, how to say, with great steps. We have to reduce dramatically the number of hyperstructures that defined in the same set, and it is easy to cover all the axioms or the needs that physicists and chemists have. I don't know how to explain more.
Very clear. No, this is very clear.
You remember Professor Sandili in Nepal, when we were with Professor Davas in the audience, and you asked us, we want to have one unit element, one inverse element for each element, and so on. And we answered you in a few hours about this. But you see, we asked you to explain what do you mean, and when we understand these restrictions, it was very easy for us to transfer it, and so we obtained that we called then the E hyperstructures.
Well, in physics, it's relatively simple, but in biology, Thomas, I'm not a biologist, so we need a biologist. For instance, we will,
yes,
I know what is needed. We will need a biologist, for instance, regarding the water. We need a biologist that indicates what type of connections or water molecule belonging to a living organism as with other component. I think they will know the answer. But once we have that knowledge, that chemical knowledge, then this can be easily transformed into axioms. And in the first quantitative representation of the difference between organic and inorganic molecules. So it's something that I personally consider very, very, very stimulating.
The same thing, do you remember that Professor Davas with some biologists defined about the blood categories, and it was very easy to reconstruct this ASV hypergroup.
Yes.
It was very easy. But the problem is how to, we the hypergroupists, to understand from you the exact application. This is the problem.
Yeah. in this case, we need a biologist. Is beyond that.
Yes, yes.
At my age, I'm 85 years old. I cannot
No,
I don't have time to go to a biology school. Sorry.
But you gave a problem for 1 million years. You give about DNA. So we have to ask how these DNAs can be composed in order to have the new DNA. DNA is not one DNA, but a lot of them.
DNA code 1,000 will take 1,000 years to mankind.
Okay.
Okay, now I have question number 5. This question is for Professor Santilli. I am curious what the draw of the algebra architecture was. Open bracket. You framed it as being the result of a year in a math library, but what was the ha-ha moment? Close bracket.
And this is basically what can allows a solution, or at least an answer to that. So at the beginning, one can see the Lie product and the representation of the external term in the analytic equation required a generalization of this Lie product in such a way to break the last property, which is anti-hermiticity, because anti-hermiticity represents reversibility, and that is the origin of the incompatibility of quantum mechanics with the physical reality, which is the thermodynamical laws. So what I worked out a bracket AB below, and in this one of the many forms, and but I had to know what that bracket was. So, because without identifying the algebra, I don't think my PhD thesis would have been, in any case, will not satisfy me. So I was certain that a mathematician had classified that algebra had been identified by a mathematician, but I had to locate, the technical source. I was, at that time, I had the honor, even though I was very young, to have the chair of nuclear physics at the Avogadro Technical Institute, so I could wait my thesis. I delayed my thesis for essentially 1 year. And I started searching all the mathematical libraries. Then I believe finally in a mathematical library, I believe in Paris, if I remember correctly, but some time has passed. I located a paper by the American mathematician Albert, and paper 1948, in which he introduced an algebra which he defined as being Lie admissible and or Lie and Jordan admissible. Those are algebras which I define in my tutoring lecture, but I can say an algebra is Lie admissible. An algebra with a given bracket is Lie admissible when the attached antisymmetric bracket AB minus BA, where AB is the abstract product, is Lie. And it is Jordan when AB plus BA is Jordan. So when I located this was just a definition and then very abstract mathematical treatment by Albert. But immediately recognized, but without any realization, but nevertheless I immediately realized that, that the algebra that I was presenting is indeed jointly Lie and Jordan admissible, because it can be decomposed into the sum of a bracket which is totally antisymmetric plus a term which is totally symmetric. And therefore, this algebra was indeed jointly Lie admissible and Jordan admissible. This coverage, so to say, of the Lie admissible and Jordan admissible character of the algebra, which is the algebraic structure of the hadronic mechanics, is at the very ultimate foundation of hadronic mechanics, and therefore is at the ultimate foundation of the proof of the EPR argument. Is very important because basically, from an algebraic viewpoint, what now we know after 50 years of study is that at the classical level, the Lagrange, the irreversibility is represented with external terms. So the historical issue, how do we represent those external terms, non-existent in 20th century orthodox physics, How do we represent them algebraically? It turned out that they are represented by Jordan algebras, by the Jordan content, namely the totally symmetric component of the algebra represents the external terms. And these are the fundamental implications for the development of the theory for the industrial application. You see, when we write a model for nuclear fusion, we look for a Jordan content, because if there is no Jordan content in the algebra, we have no representation of irreversibility. In this case, ladies and gentlemen, I respect the work of others, but personally, I'm not interested, because the nuclear fusions are structurally irreversible, and if we don't represent the irreversibility, we miss a huge chunk of ingredient. Not on mathematics or algebra. No, those that are turned into engineering mechanism for the So the aha moment was very nicely put by Dr. Boni, and I want to thank him. Incidentally, Dr. Boni, I hope I'm sure you are in the audience. Your lecture has been considered one of the nicest of all the entire conference. I would like to compliment you. It was a beautiful lecture. It was so stimulating. So using your language, your beautiful language, American language, I love it. Yes. What is a ha-ha moment? The aha moment when finally, after months of searching those old library, looking at old books, when I finally discovered, I open up this old volume, I discovered the definition of Lie admissible algebra. The thrill of discovering in that moment is undescribable. So it is not only ha-ha, it's you, very much bigger. But thank you for the beautiful question.
So we have question number 6, which is for Santilli. What is the form of Einstein determinism you proved?
This is a delicate, is a question that is very, very delicate, because in principle, one can define any virtually endless form of quote Einstein determinism, end of quote. Our work has been technical, and our only answer is via equations. Even though we invite epistemological study, discussions, yes, but however, by keeping in mind what the equations are, otherwise we exit from science and we enter into something very interesting, but not related to our study. The equations that we have essentially introduced is that the product of the delta R and the delta P of the standard deviation, the product is proportional to the value, to absolute value of the isotopic element. This value becomes very, very small in the interior, under strong interaction in the interior hadron, nucleus star. It decreases with the increase of the density, and the value of the isotopic element tends to be identically 0 at the limit of the Schwarzschild horizon, by therefore recovering in full, in totality, the Einstein determinism inside a black hole. So the conventional definition of determinism can be only mathematically formulated in the interior of a black hole. But ladies and gentlemen, this requires some thinking before venturing statements or view. Why? Because after 1 century of thinking, the uncertainty has been referred to particles that are free in vacuum. This has been the 1 century of thinking, uncertainties of particles free to move in all directions in vacuum, under which condition Heisenberg uncertainty are absolutely valid beyond any doubt. So we're talking a totally new environment. Particles that are frozen in the interior, ultra hyperdense medium as in the interior of a black hole. That's what opens a number of very intriguing epistemological questions that, ladies and gentlemen, I'm sorry, I do not want to, it's not my expertise, so I will be delighted to consider and discuss, but it's not my field. I have one final point, namely the isotopic element is structurally dependent on the relative distance in between particles. So not only it tends to 0, sorry, not only tends to, and then the density and many other very complicated elements. So it tends to zero with increase of the density, yes, but it also, there is a dependence, not so much investigated in the literature, but maybe of interest of some researcher. There is a dependence on the relative distance between the particles, and tend to zero when that relative distance is bigger than what we call the hadronic horizon. What is the hadronic horizon? Hadronic horizon is the radius of the sphere in which the quantum mechanics becomes excessively approximately valid in favor of the completion of quantum mechanics, of hadronic mechanics. The point I want to make is that the transition, this has not been investigated, but invite interested colleagues to do so. Namely, the equations that we have produced appears, I repeat, appears to allow a smooth transition between this new determinism, which I call isodeterminism, technically it's called isodeterminism, and the conventional Heisenberg determinism. Yes, it's not an abrupt the transition, you know, with the boundary weight. No, appears to be a very, very smooth transition, but it has not been investigated. Thank you for the question, very important indeed.
Okay, I have another question, number 7. This is for Santilli. Professor Santilli, do you know of a classification of hadrons other than that by the standard model? Maybe it's also for other panelists. I'm not clear here.
Perhaps you can answer this question, and then I'll also make on. Thank you.
The issue of classification is that once you admit, well, you have to, you know, understand the geometry in which I worked was geometry of points, lines, and planes, which correspond to points are particles. Then you have planes, you know, I mean, lines are fields, and then planes are currents. So when you say a point is topologically equivalent to a sphere. And if you eliminate the, you know, if you expand the point to a sphere, then the sphere is, you know, defined as envelope of its tangent lines. And therefore, you know, the differentiation between particles and points, you know, I mean, between spherical, you know, the shape becomes very, not too important, but the topology. That is, whether you are talking about currents. When they say the measuring box, it might be currents they're measuring. It's planes, and you're not going to see the plane coming out as a point. And you will find in the paper I presented that I emphasize replacing a point charge by a current loop. And the current loop has a different signature. I think that this is all I need to say at this point. Thank you very much.
Thank you, Professor Alimalu. Yes, I would like also to answer this question. And in my view, now the question is there an alternative to the standard model? And the answer is yes. And the answer is provided by Professor Trell classification of all particles that he achieved via the sole use of the Dinking diagrams of Lie algebras. And without any of the paraphernalia of hypothetical or ultra-hypothetical particle and conjecture, a plethora or of so many neutrinos defined by colors, and without any understanding of their physical characteristics, without any hope of their distinction experimentally, etc., etc. And so all this is missing. It's just a pure, clean, unbelievable classifications in which is, by assuming the mass of the proton and of the electron, Professor Trell, if you are listening, I apologize because I could make mistakes, but I do remember that you assume extremely few numbers. Mass of the proton, the mass of the electron, the magnetic moment of the proton, that of the electron, and with those very few data, you achieved a representation of all characteristic data of elementary particle divided in families. This classification, in my opinion, is significantly better than the classification by the standard model, because, again, not to repeat, it is not based on ultra hypothetical assumption, river of plethora of particles that whose characteristics are unknown and cannot be identified experimentally. No, it's based on concrete experimental fact. It is very unfortunate for science, as well as for mankind, and as well for the news media, that unfortunately is ultimately responsible of this situation, that Professor Trell, the Professor Trell model could not even be considered by orthodox academia due to the dominance of the standard model, despite the litany of insufficiency, some of which have been brilliantly reviewed by Professor Boni 2 days ago. Incidentally, we did broadcast Professor Trell lecture yesterday at the end of the session, because we received the lecture after everything had been organized. And in this lecture, not only shows the classification of particles, but he keeps going and shows how with the same principle, always based on the Dinking diagrams, he can represent essentially, he achieved an alternative classification of atoms, more specifically of nuclei, and which is absolutely remarkable. And then push this classification to its ultimate capability, which is interconnection and as we say, entanglement, as he put it in the title of his talk, the entanglement of the entire universe. So he ends up with what we have already achieved by alternative ways. This is Professor Boltzmann lecture, in which we recall that the wave function of one electron fills up the entire universe. So the universe is totally entangled, because it's made up of constituents in total continuous entanglement, therefore communication. So he achieved that by just starting from the Dinking diagram. It was a majestic lecture of Professor Trell that will be available is not yet available in YouTube or in our web, because we receive it so late. But definitely we will make sure it is part of our list of lectures. Thank you for your attention.
Okay, I have a question number 8 for all panelists. I read somewhere that Professor Santilli went to Tallahassee in 1981 to consult Professor Paul Dirac for the removal by hadronic mechanics of the divergences of quantum mechanics.
Simone, any comment?
I heard some accounts of this meeting, but of course I was not there, so I can only see. For what I know that yes, Professor Santilli had a meeting with the late Paul Dirac, and he was also very interested in his studies. But unfortunately, due to his death, he was not able to go deeper into these problems. But probably Professor Santilli will have more to say about this.
Well, yes, the case is true. I was at the Lyman Laboratory of Physics, and we had communal meetings, and with top famous professors, were the graduate students, and I was there also with my own associate, and also graduate student from Belgium. Anyhow, so I remember there was it was kind of a negative judgment against Paul Dirac. Paul Dirac is one of my mentors. I love him. I mean, I really honor him because his intuition. I used the symmetry of his equation with the isoself duality as a model for the entire universe, just to have an idea of what Paul Dirac means for me. So the moment I heard that Paul Dirac was kind of knocked down because he had suggested the search of a completion or a generalization or an enlargement of quantum mechanics in such a way to remove the divergency. In the last years of his life, Paul Dirac indicated very, very clearly that in his view, it was not possible to construct knowledge that will resist the test of time and have a very serious prediction of usefulness with primary use for society if the prediction of the theory are ultimately have an infinite value, and then the infinite value is subtracted somehow with a mechanism and with some complicated formula out of the infinity we extract a number. He said the number that is extracted out of infinity has no final physical value. That was his view. And it is a view that was very, it is still now very, very important. It's a teaching for particle physics laboratory that they continue to ignore to their detriment, jointly with the ignorance of the teaching by oblivion over the teaching by Einstein and lack of completion, etc., etc. So the moment I heard that, I stopped everything I was doing. I went home, I told my wife, Carla, I got to go to Tallahassee. Professor Dirac was there, he had retired from England, retired there because of the weather. And indeed, I did have this meeting. I waited sometime, he was kind of old. Indeed, he died a few years later. And essentially, and he became curious, and I was very young at that time and very intimidated by the presence of this, of my primary master. I will never forget. And so he asked me, you know, he was very quiet person, very meditative. He asked me what I wanted to indicate. And what I told him is essentially, it's here. Let me go back to speaker view so that people can see. What I presented to Professor Paul Dirac is essentially here. Namely, what I told him that the enveloping algebra of quantum mechanics is conventional product AB that you see on the top. As a result of this, the perturbative series, conventional perturbative series that you can see in the second line are divergent, because except in rare conditions, they can be weakly convergent or this thing like that. So I told him at that time, quantum mechanics was far from maturity, but this axiomatic structure had been very well identified. And so the third line, you can see there, I told Professor Dirac, so why don't we enlarge the product, the associative product, sandwich in between a quantity T that can represent non-Hamiltonian interactions. Because if we do that, then the perturbative series above is turned into the one on the third line. And then if the absolute value of this element T, that I called them the isotopic element, because at that time we had 2 volumes on hadronium by Springer-Belag and many papers from Mark. If the absolute value of T is sufficiently smaller than 1, the series above, which is divergent, can become into a strongly convergent series, so fastly convergent that basically is enough to consider the second or the third term of the expansion to achieve, of course, under the assumption that the absolute value of T is sufficiently smaller than 1. Well, what happened after that is unforgettable, because I stopped. I was afraid to be hit. You know, so instead, what he did, we were sitting on a small table. He lifted up his body and he started walking next to me, back and forth. And this lasted a couple of minutes in total silence. Of course, I was totally silent. As you know, the people have met Professor Dirac. He was a very taciturn person. So. And after 2 minutes, I could see his mind, his eye, he was thinking. And he came back to me and he said, Dr. Santilli, please send me your papers. That's all he said. That's all he said. And of course, I went back and I sent to him a paper with the mathematician, Professor Yul-Chun Jung, in which we formulated the iso-Hilbert spaces. Unfortunately, it appears that those papers were never received by Professor Dirac. He became ill several months later, and then he died. And And this was extremely unfortunate because in the event this meeting had happened a few years early, I believe the history of physics would have changed, and the science would have been much more credible today in the event of Professor, the beautiful image, the Nobel laureate Paul Dirac was still alive. One final comment. This conversion of diversion into strongly conversion has been then proven in a number of papers. I just want to mention two papers with the chemist Don Shilledy, Professor Don Shilledy from Virginia Commonwealth University, which I quoted as confirmation of the third proof, apparent proof of the EPR argument, in which we worked out I had worked out the isoelectronium as a strong bond between the valence electrons. And then we used this notion to work out, to calculate all the characteristics of the hydrogen and the water molecule. And we stated in that paper that among various things that the series, the perturbatism, the area, all series. This is the statement that you can read in those two papers. That all the series perturbative or other series, I don't remember the technical name, but they say all series used in the calculation have a convergence at least 1,000 times faster than conventional quantum mechanical series. Ladies, what you should know that the paper is not, the statement is not correct. In reality, the conversion was much bigger. We were talking about, we had calculated at least 10,000 times faster the convergence than conventional series. But with Don Shilledy, we decided not to state it because they said that nobody will believe us. So we decided to put, the number 1,000, which was 1/10 of what we had calculated, just because I thought it was enough. 1,000 faster was enough to show that indeed, hadronic mechanics and chemistry do have indeed, can indeed achieve. I had recommended the view of this conversion, Professor Vojuklis. Perhaps it's another mathematician that can help us. This is something also I had recommended to Professor Georgiev. It is my opinion that in view of this very extreme convergence, as fast as desired, it depends on the numeric value of the isotopic element. However, keep in mind the isotopic element has to represent physical reality, because we are signed with physics. So it has to represent, in the case of the particle, has to represent the density, the temperature, and the sun, etc. But my recommendation to Professor Georgiev is that that somebody should apply this new isomathematics for the weather forecast. Why? Because weather forecast is becoming now is becoming now too slow for contemporary. Well, I should say no. The weather forecast, they do very fast calculations. But careful. Here is the point: they are approximately valid due to the complexity of the data. So there is no doubt in my mind that by using isomathematics, all those enormously complicated series could be simplified dramatically, if nothing else, rather than using an enormous computer, we can use a smaller computer. And then if the characteristics of the weather forecast, such as temperature, in this case of the atmosphere, pressure, and the variation, remember, isomathematics is non-local. So T represents the volume in which there can be clouds and not points. Then in this case, we can have there is, at least it's worth investigating in my view. Thank you for your attention.
Okay, now I have question number 9 for Santilli. I also read that Professor Santilli contacted Werner Heisenberg in the early 70s on nonlinear theories. Is that true? And if so, what was the outcome?
Well, this is the last question answered, then that's it. Yes, it is true. Werner Heisenberg, that's why I always studied the originator of theory, always. And I read occasionally some of their followers, but I always been inspired by the originator, Einstein, Lorentz, etc. Now, in this case, as we know, Werner Heisenberg, who originated quantum mechanics, he knew about its primary limitation, which was its linearity. The theory is just too simple in structure to represent the complexity of life. So when Heisenberg dedicated the last year of his life for a form of broadening of quantum mechanics into a non-linear theory, which incidentally the historian should look at this work very carefully, because that qualifies indeed as a completion of quantum mechanics 100% along the inspiration of Einstein-Podolsky-Rosen argument. When Heisenberg wrote also what his last book, monograph, was precisely on nonlinear theory. What was there now? I was in the faculty at Boston University at that time, and heard about that. Of course, quantum mechanics. I had abandoned studies on hadronic mechanics because there was no interest in America at that time, and so. But I heard, but my mind kept looking at it. But I heard about the nonlinear study by Heisenberg. I immediately wrote to him. He answered very, very nicely, even though he knew that I was a little professor of physics. I was associate professor at Boston University. It was very nice. We had a little exchange, and then but then I hesitated to I reached a point, and then I hesitated to go further, and our relationship ended. Our contact, at that time we would write to each other by mail. And what was the problem? The problem is that the conventional, again, is a fundamental issue for hadronic mechanics, for everything that we are doing, recycling nuclear waste, everything that we are doing. This is the very essence, one of the many assets. So what was the problem? The problem is that nonlinear theory violate, generally, to my knowledge, they generally violate the superposition principle. Namely, we have a bound state in quantum mechanics. That's why quantum mechanics is so beautiful when applicable, because you have a bound state, and in quantum mechanics, you can indeed identify the constituents, and you can identify and define them and verify them. This is one of the beauty of quantum mechanics, again, when applicable. However, when you add the nonlinear theory, and you violate the superposition theory, then this is de facto implies the impossibility, to the best of my knowledge, to identify the constituents. So therefore, so that's that. When we reach that point, I did not want it to appear uncourteous or such a giant and a person that I really honor, and I was honored by his email, and it ended up. But the point was, the point that remained in my mind for the rest of the year. Finally, when I reached Harvard, that's the problem I confronted head on, like confronting a bull. It had to be solved. And namely, because without achieving a nonlinear theory that verifies the superposition principle, so that we can define and work on the constituents. Ladies and gentlemen, I was not interested, to be honest with you, because I knew that I could not apply. And this was achieved thanks to isomathematics. Again, thanks to the embedding of all nonlinear terms into the iso unit. That's the necessity of iso numbers and the entire machinery then that follows. So the teaching first of all, the honor that I received was great, and I remember the rest of my life. But the teaching by Heisenberg, the idea of the necessity of enlarging quantum mechanics into a nonlinear theory is not Ruggiero's idea. No, it's an idea that originated from the founder of quantum mechanics, Werner Heisenberg, that I want to honor to this day.
Okay, we have now question number 10. And Professor Animalo, you need to unmute yourself, I think. You have to do it to take off to be able to talk. Because the question is for Professor Animalo and Santilli. I'm an experimentalist at CERN, and it is stated in the literature of hadronic mechanics that, quote, numerical results released by experimentalists at CERN are a personal opinion by the experimentalists themselves, close quote. please explain how this is possible for experimental papers authored by hundreds of physicists.
I would like to refer you to my paper in which I did point out that in fact, I should begin with my contact with Professor Dirac. When I was, after I had done all the, going to Cavendish Lab, Cambridge, and then going to W.W. Hansen Lab in Stanford, California. And then I eventually, before I went to Drexel, I got to a place in Missouri where I was asked to teach high energy physics because I did not, I'm a solid state physics and mathematician by training. So I wrote Dirac. I wrote him a letter and say, what is wrong with Einstein's theory? Why is it that, because the people I have here don't understand differential geometry and they don't understand, well, they understand differential geometry, but it's difficult to explain to them why the unified field theory, why Einstein could not unify electromagnetism, which is gravitational theory. So the answer which he gave me was that in the, you know, the G-mu tensor, that is the metric tensor, that is based on a quadratic form. And on a binary quadratic form, any antisymmetric, you know, quantity disappears very space. And therefore you have to generalize to go to be able to include both symmetric and anti-symmetric, which goes to the heart of hadronic mechanics. And basically, the question boils down into, in terms of the problems of Feynman diagram without divergences on issue of supersymmetry. That is second quantization. The point is that the usual classification, if you don't, one of the reasons why Dirac went into looking for positive energy relativity wave equation was that second quantization. When you get the positron and so on, you have to second quantize to be able to interpret the result. And it's in that second quantization that problem arose that you have what is called fermion interaction going into in a single vertex, or boson-boson interaction going into fermion, that is supersymmetry. And this includes all everything that is being said. So the main point of it is that it is scale invariant, that the theory has to be scale invariant. And this is the emphasis of what my interest, I found it was particularly interesting because then I didn't have to use supercomputers, binary results. And if you look at the scatter in the result and the result I gave, in the paper which I submitted, you find that those graphs were reduced to the scale invariant. And when you're doing scale invariant theory, infinity has no place. Okay, what is how does infinity scale? It's between 0 and infinity. Once you can fix 0 and infinity, everything else is negotiable. I think this should be enough. Thank you.
First, I would like to thank this colleague from CERN that apparently personally participated in our meeting. Thank you. It is appreciated. Also, the question is very, very pertinent, and indeed, it is it is baffling in a way because our well, apparently there are doubts on the numerical values, of the number released by CERN. But why, if that is the case, why? What's the origin, and what are the responsibilities? So the question is extremely important for. As far as speaking personally, I'm expressing my viewpoint in the third tutoring lecture, which is available on the World Lecture Series at level 12, dedicated to this and also it's available. The lecture, the link is available in the announcement of the. So there is no point in my repeating those questions. They are indeed numerous and they are rather serious in our view. I only want to attract the attention on one point of that lecture, the concluding part, namely that let's forget the past. The past, this was a point that was touched also during the lectures. You see, the comparison was with nuclear physics. You see, it was mandatory when the nuclear physics started to conceive nuclei as a collection of protons and neutrons. There was no other alternative. We learn later that this conception prevents the representation of basic experimental data, such as we cannot represent exactly the spin, magnetic moment, etc., etc. We learned this later, so therefore we had to go to the next step, which is essentially the isoparticle, isoproton and isoelectron. They achieved for the first time representation of the stability, nuclear magnetic moment, nuclear spin, etc. But of course, thanks to isomathematics. Well, for the scattering experiment at CERN, Fermilab, it is the same. When all these experiments were initiated, there was no other alternative. And I, in the position of the director of those laboratories at that time, I would have said yes, namely use the Feynman diagram. It was the logical way, the sound way to go. But later, with the passing of time, we discovered that while the Feynman diagram are fantastic, but exactly valid for electromagnetic interaction, they have a serious limitation for strong interaction or for high energy density collision, especially in view of the Einstein-Podolsky-Rosen argument. So that it is an evolution, a natural evolution. And but what is unquestionable that Einstein-Podolsky-Rosen argument, if not only confirmed, it has been apparently confirmed in various papers, but if it is eventually accepted, as I stated in my opening lecture, if it is accepted by the scientific community, implies necessary revision of the basic instruments used in the data elaboration of particle data at CERN, Fermilab, etc., with particular reference to the relativistic scattering theory. Because then, if the EPR legacy is correct, their revision is unquestionable. We can debate what revision, yes, of course, but it is evident to be non-trivial as to be a non-unitary, and therefore you go into the universality of iso-unitary. You end up in any case with a small particular case of iso-unitary. In conclusion, my recommendation: let's forget the past. And let's think of the future, and let's above all debates, because let me emphasize that this was a point stated in that I must recall on my lecture, tutoring lecture 2. We do not claim to be wrong. We are scientists. We do not claim to be absolutely correct. No, we just have our own doubts like everybody else. However, what we recommend to colleagues at CERN, Fermilab said, is to have the same scientific behavior, namely, be careful before claiming that their number based in disagreement with EPR argument are final numerical results. No, they should exercise, they appear, the way we say it appears that we have done this. They should say it appears that the mass of the intermediate particle is so many GeV. It appears. When they claim it and they venture it, thanks to the complicity of news media, which we debated, this is one of the primary responsible for the ongoing problem in science, is the news media is the primary responsibility. Then in this case, but if they present it as most plausible as possible, as this will be, then there is no problem. Then the future will decide the outcome. But the question the posing of the question has been sincerely appreciated.